Why are these bridge piers curved? Wouldn't straight ones work? First, let's take a look. This is an elevated highway bridge in a city. It consists of piers, a cap beam, and the bridge girders. The load from the girders is transferred to the cap beam, then from the cap beam to the piers, and finally, into the ground. This structural system transfers forces in the most direct way. However, not every site allows this arrangement. Sometimes, a bridge pier would end up standing right in the middle of a roadway, where passing vehicles could easily crash into it. A simple solution might be to move the pier into the center median, but doing so creates long cantilevers on both ends of the cap beam. Every extra meter of cantilever dramatically increases the bending moment at the root of the beam. If the cantilever extends about 4 meters, the cap beam may need to be as much as 1.5 meters deep. The amount of concrete and reinforcing steel could nearly double. Excessive cantilever length also causes greater downward deflection of the beam. So what can be done? There are 3 possible solutions. First, add more bridge piers to shorten the cantilever. However, doubling the number of piers greatly increases construction costs. Second, make the cap beam much deeper. But this raises the bridge deck, complicates the design, and significantly increases the project budget. Third, use an A-shaped bridge pier. The 2 inclined legs converge at the bottom and are placed within the medians on either side of the road. The sloping legs support the cap beam from the outside, effectively shortening its cantilever span. This greatly reduces both the bending moment and deflection, allowing the cap beam to be thinner and requiring less reinforcing steel. However, the inclined legs generate outward horizontal forces, which tend to push the legs apart. The clever part is that the cap beam itself acts as a tie beam. The section of the cap beam between the 2 inclined legs is placed in tension, pulling the legs tightly together and creating a stable frame structure. As long as this portion of the cap beam is designed as an eccentrically tensioned member with sufficient tensile reinforcement, the entire structure remains extremely stable.